Good night, my name is Hugo Villarreal and my work focuses on the development of a calibration curve for an X-ray diffractometer using zinc oxide sample as reference materials. In this work, we focus on the broadening of diffraction peaks, but there is a small complication. The broadening we observe in the peaks does not come only from the sample, it also comes from the diffractometer itself, and we know as instrumental broadening. The need to evaluate the instrumental broadening in X-ray diffraction arises from the impact on the accurate interpretation of diffraction profiles, especially when the analysis focuses on microstructural properties. This work aims to develop a calibration curve for instrumental broadening as a function of the diffraction angle issued as zinc oxide standard. The objective is to analyze the angular variation of the full width at half maximum, obtain an equation describing its behavior in the X-ray diffractometer, and establish a methodology that can be applied to develop calibration curves for other diffractometers. For this purpose, we work with two zinc oxide samples. The first sample was synthesized using the citrate-nitrate salt gel method, and the second was synthesized using Zimcolite. Then both samples were annealed in a muffled furnace for 24 hours under two conditions. The first have a continuous annealing, and the second have a discontinuous annealing with an intermediate cooling period of 7 hours. Then the samples were characterized by a pananalytical expert probe diffractometer with copper radiation in a Bragg-Brentano geometry. The diffraction profiles were fitted and refined, obtaining the peak position, intensity, and FWHM for each diffraction peak. And the data obtained were statistically analyzed by comparing the FWHM values among the samples to determine which sample showed the most suitable behavior, considering its variability and FWHM values. Once the sample was selected, an individual moving range and range standard analysis was performed to evaluate the behavior and variability of its measurements. After completing all the analyses, we determined that sample 3 was the most suitable and best met our conditions for use as a calibration standard. Finally, we obtain a polynomial equation describing the relationship between FWHM and diffraction angle and plotted the calibration curve for sample 3. The instrumental broadening behavior was successfully modeled using a second-degree polynomial fit, accurately describing the FWHM response of the pananalytical expert probe diffractometer. The resulting model can be used as a reference to evaluate the instrumental contribution to the FWHM in future measurements.